All right, today we're tackling a true SQL classic, how to find the nth highest value in a table. Now, this might sound simple, but trust me, solving it efficiently is your key to unlocking some of SQL's most powerful features.
So, have you ever seen this one before? If you've prepped for any kind of data role, I'm willing to bet you have. Finding the nth highest salary is, without a doubt, one of the most common SQL interview questions out there. But it's so much more than a trivia question. It's a gateway to really understanding how to rank and analyze data properly.
So here's the challenge. Imagine we have a simple employee table. The goal is to write one query that can find, let's say, the second or the third, or maybe the 10th highest distinct salary. And you've got to pay attention to that word, distinct, because in the real world, you're going to have multiple people earning the exact same salary. That's a key detail.
And believe me, this isn't just some abstract puzzle. You use this kind of logic all the time. It's essential for ranking employees for performance reviews, figuring out salary trends, calculating bonuses, or even identifying your top-selling products. It's a fundamental building block for data analysis. So, how do we actually do it? Okay, so the first place most of us start is with a subquery. A query nested inside another query.
It makes sense, it's pretty intuitive, and for a simple case, hey, it works.
The logic is actually beautifully simple. Let's say you want the second highest salary. Well, what do? First, you find the absolute number one highest salary. Got it? Okay. Then you just ask the database, hey, can you find me the highest salary that's just a little bit less than that top one? It's a two-step thought process that we can write as a single query. And here's what that looks like. Let's break this down real quick. The part in the parentheses, the inner query, runs first. It goes through the whole table and finds the single highest salary. Let's say it's 100,000. Then the outer query kicks in. It says, okay, find me the max salary, but only look at the salaries that are less than 100,000. Boom, you get the second highest. It's clever, for sure, but as you'll see, it's not exactly the fastest way to do things. So let's move on to a much more direct approach. This one is super popular in databases like MySQL and PostgreSQL, and it uses two handy keywords, limit and offset. Now, the logic here is really intuitive. It's like you're just counting down a list with your finger. First, you tell SQL to get all the unique salaries and sort them from biggest to smallest. Then, if you want the nth value, you just tell it to skip the first n-1 rows and grab the very next one. So, to find the third highest, you just skip 2 and take the next one. Simple as that. And this gives us a really clean, powerful, and general query. Let's look at the pieces. Select distinct salary. That makes sure we're only dealing with unique values. Order by salaried desk. That sorts them from high to low. And here's the magic. Limit 1 says, I only want one result back. And offset n-1 tells it how many to skip. So to find the fifth highest salary, n is 5, so you offset by 4. It skips the top 4 and grabs that fifth one. It's so readable and direct. So, why is this so much better? Well, it all comes down to performance. That first subquery method can actually force your database to scan the same table multiple times. On a huge dataset, that can be incredibly slow. The limit and offset method, on the other hand, is way more efficient. It just sorts the data once, then picks out the exact row it needs. It's really the difference between reading a whole chapter over and over again versus just flipping to the right page from the start. Just a quick heads up here, and this is important. While this method is fantastic, the exact words you type can change depending on your database. MySQL and PostgreSQL use limit and offset, but something like SQL Server uses a slightly different syntax, like offset with fetch next. So as always, double-check the documentation for whatever system you're working with. All right, now let's get to the most powerful, the most flexible, the professional solution, window functions. If you're dealing with messy, real-world data where you have ties and all sorts of complex ranking scenarios, this is the toolkit you absolutely need to master. This is where SQL really starts to show off. So what the heck is a window function? Well, in simple terms, it's a function that does a calculation across a set of rows, a window, that's related to the current row you're looking at. It lets you see each row in the context of the rows around it, which, as you can imagine, is perfect for ranking things. And this is why they are so important. Functions like dense rank are specifically built to handle ties correctly. I mean, think about it. If two people are tied for the highest salary, the next person should be ranked second, right? Dense rank makes sure that happens. For data integrity, that's a huge deal.
So let's zoom in on the two heavy hitters for this problem, rank and dense rank. They sound almost the same, but the way they handle ties shows a critical difference, and picking the wrong one can completely change your results. Okay, look closely at this table. Row number, it just gives every single row a unique number. Not what we want for ranking salaries with ties. Now, focus on the salary of 1,500. See how there are two of them? Both rank and dense rank correctly give them a rank of 2. But look what happens at the next salary, 2,000. Rank jumps to 4. It skips rank 3 entirely because 2 rows were tied for second place. But look at dense rank. It gives the next salary a rank of 3. It never leaves gaps. Same thing with that 3-way tie at 2,500. Rank goes from 6 all the way to 9. Dense rank just goes from 5 to 6, exactly like you'd expect. So to really nail this down, just think about a race. With rank, if 2 people tie for the silver medal, there's no bronze medal winner. The next person gets 4th place. But with dense rank, if 2 people tie for silver, the very next person still gets the bronze. For finding the nth highest salary, dense rank is almost always the one you're going to want.
And here's what that looks like in a real query. I know, it might look a little intimidating, but it's really just 2 simple parts. The inner query, the part in parentheses, runs first. It creates a temporary table that has the employee's name, their salary, and a new column we're calling ranking. And that column is created using dense rank over order by salary DESC. That's what does the magic gapless ranking. Then the outer query just says, okay, from that temporary result, just give me the rows where the ranking equals whatever n I'm looking for. It's powerful, it's safe, and honestly, it's the standard for this kind of work. Okay, we've just covered 3 totally different ways to solve the same problem. So the big question is, which one should you actually use and when? Let's wrap this up with a quick practical summary. So here's the breakdown. The subquery is easy to understand, but it's slow on big tables. It's fine for a quick one-off lookup. The limit and offset method is simple and fast, but remember, the syntax can be specific to your database. It's great for quick queries when you're not too worried about ties. And finally, window functions, like dense rank. They might look a little more complex, but they handle ties perfectly and are the gold standard for most professional situations, especially when making sure your data is 100% correct is the top priority. At the end of the day, finding the nth highest value isn't just about passing an interview. It's about mastering the art of ranking data. It is a genuine data superpower that lets you slice and understand your information in much deeper ways. So now that you have these tools in your belt, think about the data you work with. What hidden patterns or insights could you uncover if you started looking beyond just the average or the maximum?